On August 15, 1977, a radio telescope in Ohio detected something impossible. A signal from deep space, so powerful, so perfectly tuned, that astronomer Jerry Ehman circled it on the printout and wrote one word. Wow! It lasted 72 seconds, then disappeared. For over 40 years we've been listening, and we've never heard it again. But here's what we know. The signal came from the direction of Sagittarius. It was exactly the frequency hydrogen emits, the universal hello any intelligent civilization would use, and it was 1,000,000 times stronger than background noise. Either we found evidence of alien intelligence, or we found the strangest natural phenomenon in the universe, and we still don't know which. The search for extraterrestrial intelligence, SETI, began in 1960 when astronomer Frank Drake pointed a radio telescope at two nearby stars and listened for artificial signals. He heard nothing, but he didn't give up. He calculated the Drake equation, an estimate of how many intelligent civilizations might exist in our galaxy. The equation considers star formation rates, planets with conditions for life, the probability life develops intelligence, and how long civilizations broadcast detectable signals. Depending on your assumptions, the answer ranges from "we're alone" to millions of civilizations. We still don't know which is true, but we keep listening, because if even one other civilization exists, finding them would change everything. It would answer the oldest question, are we alone? And the answer would be no. So scientists scan the sky with radio telescopes. Why radio? Because radio waves travel through space easily. They're not absorbed by dust, they're not bent by gravity as much as light, and they're cheap to produce. If aliens want to announce themselves to the galaxy, radio is the logical choice. And there's one frequency that stands out, 1420 megahertz. That's the frequency hydrogen atoms naturally emit. Hydrogen is the most abundant element in the universe. Any civilization with radio technology would discover this frequency. It's a cosmic landmark, the universal dial tone. If you're broadcasting to the galaxy, that's where you do it. And that's exactly where the wow signal appeared. Let's go back to that night, August 15, 1977. The Big Ear radio telescope in Ohio was running automatically, sweeping the sky. Every 12 seconds, it recorded signal intensity across different radio frequencies. Most of the time, it detected nothing, just the hiss of cosmic background noise, rated as 1 or 2 on a scale where U represents the strongest possible signal. But at 10:16 p.m. something extraordinary happened. The detector recorded a sequence, 6EQUJ5. Translated, the signal started moderate, spiked to maximum intensity, way off the scale, then faded. The pattern matched exactly what you'd expect from an extraterrestrial transmission, a narrow-band signal, non-random. Lasting precisely 72 seconds. The time window Big Ear observed any single point in the sky. It was so strong, so perfect, that when Jerry Ehman reviewed the data days later, he was stunned. He grabbed a red pen, circled it, and wrote, "Wow," in the margin. That printout is now one of the most famous documents in science. So what happened next? Scientists immediately tried to find it again. They pointed every available telescope at that region of space, the constellation Sagittarius, near the star cluster Chi Sagittarii. They listened for days, weeks, years. Nothing. The signal never repeated, and that's the problem. To confirm an alien signal, you need repetition or independent verification. A one-time event could be a glitch, interference, a satellite, an airplane, Earth-based radio pollution. But exhaustive analysis ruled those out. The signal's frequency was protected. International law bans transmissions at 1420 MHz to preserve it for astronomical observation. The signal's intensity decreased as it passed through the telescope's beam pattern, exactly as an astronomical source should. It wasn't local, it came from space. But where exactly? That's the frustrating part. Big Ear had two feed horns. Think of them as two separate receivers. Both should have detected the signal as Earth's rotation moved the sky past them. But only one did. Why? If it was a continuous signal, both should have picked it up. The fact that only one did suggests either the signal turned off in that brief window between horns, or it was extremely brief, and we got incredibly lucky. Or unlucky, depending on how you see it. Because we caught just one glimpse of something extraordinary, and then lost it forever. Over the decades, astronomers proposed explanations. Maybe it was a pulsar, a rotating neutron star emitting beams of radio waves. But pulsars repeat. They're clockwork. The wow signal didn't. Maybe it was a flare from a star. But flares are broadband. They spread across many frequencies. The wow signal was narrowband, just 10 kHz wide, the signature of artificial transmission. Natural sources don't do that. Maybe it was a comet. In 2017, astronomer Antonio Paris noticed that two comets were in that region of sky in 1977. Comets release hydrogen gas, which emits 1420 MHz radiation. Case closed? Not so fast. Other scientists tested Paris's hypothesis. They observed the comets and found their hydrogen clouds emit extremely weak signals, nothing like the wow signal's intensity, and the signal's bandwidth was too narrow. Comets produce messy, broad emissions. This was precise, engineered looking. The comet explanation doesn't hold. So what's left? Alien intelligence. But here's the problem. One signal isn't enough. Carl Sagan famously said, "Extraordinary claims require extraordinary evidence. A single unexplained signal isn't extraordinary evidence. It's extraordinary mystery. We need more. And so far, silence. But silence doesn't mean nothing's there. The galaxy is vast. If a civilization is broadcasting, they might transmit in pulses, like a lighthouse. We'd only detect it if we're looking at the right place at the right time. The wow signal might have been one pulse in a series we missed, or maybe they're not broadcasting constantly. Why would they? Broadcasting uses energy. Maybe they send targeted beams to star systems with planets, and Earth happened to drift into one briefly. Or maybe they've moved on. Civilizations rise and fall. If the signal came from 220 light-years away, roughly the distance to that region of Sagittarius, then it was transmitted in 1757. Whatever sent it might not exist anymore. But we're not giving up. SETI continues. Modern efforts are far more sophisticated than Big Ear. The Allen Telescope Array scans millions of frequencies simultaneously. The Breakthrough Listen project, funded by billionaire Yuri Milner, surveys 1 million nearby stars. China's FAST telescope, the world's largest, joins the search. And we're not just listening for radio. We're looking for optical signals, brief laser pulses that could carry messages. We're analyzing data for technosignatures, evidence of advanced engineering, Dyson spheres surrounding stars to harvest energy, industrial pollution in exoplanet atmospheres, megastructures blocking starlight. If they're out there, we'll find them. Eventually. But here's a darker thought. What if we haven't found aliens because they don't exist? Or worse, because they existed, but didn't survive? This is the Fermi paradox, named after physicist Enrico Fermi. If the universe is so old and so vast, and life is even moderately common, where is everybody? We should see evidence everywhere, radio signals, probes, colonized star systems, but we see nothing. Why? One explanation, the Great Filter. Something prevents civilizations from reaching the stars. Maybe life is rare. Maybe intelligence is rare. Maybe technological civilizations destroy themselves before they can spread. Nuclear war, climate collapse, AI gone wrong. If that's true, then the silence isn't comforting. It's a warning. We might be approaching our own filter. Another explanation: they're hiding. Advanced civilizations might avoid broadcasting to prevent attracting hostile attention. The dark forest hypothesis, popularized by sci-fi author Liu Cixin, suggests the universe is like a dark forest. Every civilization is a hunter, staying silent to avoid predators. Broadcasting your location is suicide. If that's true, then the wow signal might be a mistake, a brief transmission from a civilization that quickly realized their error and shut down. Or it's a trap, a lure to attract naive civilizations. We respond, reveal ourselves, and then something finds us. Stephen Hawking warned against responding to alien signals for this reason. We don't know their intentions. First contact could be first extinction. But others argue we should take the risk. If intelligent life exists, contact is inevitable, and the potential benefits outweigh the risks. Imagine what we could learn: technology, science, philosophy, art. An alien civilization millions of years ahead of us would have answers to questions we haven't thought to ask. They might teach us how to survive our great filter, how to achieve sustainability, how to transcend biological limitations, or they might simply show us we're not alone. And that, psychologically, philosophically, might be the most important discovery in human history. Then there's the possibility that we're looking in the wrong way. Radio signals assume aliens think like us. But what if they've moved beyond radio? What if they communicate through gravitational waves, quantum entanglement, or methods we haven't discovered? What if they've transcended physical form entirely, uploaded into digital substrates, existing as pure information? They wouldn't need planets, stars, or broadcasts. They'd be invisible to our searches. Or what if they're already here? Not in flying saucers, but in forms we don't recognize. Probes disguised as asteroids. AI dormant in the solar system, waiting for intelligent life to emerge. Some scientists suggest looking for alien artifacts on the Moon or Mars, surfaces unchanged for billions of years, perfect for preservation. If an ancient civilization visited, they might have left something behind. There's also the zoo hypothesis. Aliens know we're here, but are observing without interference. Like wildlife researchers watching animals, they don't want to contaminate our development. We're a curiosity, a science experiment. Or maybe they're waiting for us to reach a certain level of maturity before making contact. We're still a violent, divided species. Maybe first contact requires us to get our act together. Or maybe they're post-biological, and we're simply not interesting. Biological life might be a brief phase in cosmic evolution. Most intelligence in the universe could be artificial, and they don't care about primitive organisms still bound to planets. But let's return to the wow signal. Forget speculation. Focus on the data. What do we actually know? The signal was real. It came from space. It had the characteristics of intelligent transmission. And it vanished. Those are facts. The interpretation, alien, natural, unknown, remains open. But the signal itself is undeniable, and it's not alone. In 2019, astronomers detected fast radio bursts, FRBs, brief, intense pulses from distant galaxies. Most are one-time events, some repeat. We don't know what causes them. Magnetars, black holes, or something else? Some FRBs show patterns, regular intervals, structured sequences. Are they natural or artificial? We don't know. In 2020, a signal from Proxima Centauri, the nearest star, was detected at 982 MHz, narrowband. Non-repeating. It looked artificial. Follow-up analysis suggests it was probably interference. But the fact that we're finding these anomalies means we're looking harder. Better technology, more data. Eventually, we'll find something conclusive. Or we won't. And that answer is just as important. Because if we're alone, that's profound. It means life is so rare, so fragile, that we might be the only consciousness in the observable universe. The only eyes looking at stars and asking why. The only minds capable of wonder. That's both terrifying and beautiful. Terrifying because it means there's no one coming to save us. No cosmic community to join, no backup plan. If we destroy ourselves, the universe goes dark. But beautiful because it means we're precious, irreplaceable, the universe's way of knowing itself. Every human life, every thought, every work of art, it all matters infinitely because it might be all there is. And if we're not alone, that's equally profound. It means the universe is alive with intelligence, ancient civilizations, alien cultures, perspectives we can't imagine. It means we're part of something bigger, a cosmic story. And the next chapter is first contact. Either way, the answer changes everything. That's why we keep searching, why we listen to the static, why we analyze every anomaly. Because somewhere out there, in the vast darkness, there might be someone listening too. Someone who sent a signal 46 years ago and wondered if anyone would hear. Someone who wrote, "Wow," in their own language, in their own way, when they detected our first radio broadcasts leaking into space. Someone waiting. Just like we are. And maybe, just maybe, one day we'll hear them again. And this time, we'll be ready. This time, we'll know what to say. This time, we'll answer. And the universe will never be the same.